Dear friends, welcome back to my YouTube channel, MCBChemTube, and this is an online chemistry tutorial. You get my previous videos from my personal homepage or from my YouTube channel. So we were discussing about the topic stereochemistry, and in this third lecture I would like to discuss with you optical isomerism, optical activity and chirality. So we will be discussing the basic concept related to optical isomerism, that's optical activity, chirality and elements of symmetry. Configuration isomerisms are two types, optical isomerism and geometrical isomerism. Geometrical isomerism we already discussed in previous lecture, and optical isomerism arises from the chirality in the molecule. The important concepts related with optical isomerisms are optical activity, elements of symmetry, chirality, and enantiomerism and stereomerism. First, let us discuss what is optical activity. What is polarized light? A beam of light consists of two mutually perpendicular oscillating fields, that is, electric field and magnetic field. Normal light oscillates in all possible direction, like possible plane, perpendicular to the direction of propagation, normal light. And plane polarized light, when an ordinary light passes through a polarizer, that is a polarized lens or Nicol prism, and when it passes through a polarizer, it oscillates only in single plane, that you can see here. So light wave oscillate in all direction without polarizer. If it passes through a polarizer, it direct only into the one plane. And this is demonstrated by using sunglass. When using a polarized sunglass, you have to polarized sunglass, and aligned perpendicular light will not permit. So light whose vibration occurs in one plane is called plane polarized light, and the phenomenon is called polarization. And optical activity, when a plane polarized light is passed through a certain substances or solution, plane of polarization is rotated either towards the right, that is clockwise, or towards the left or anticlockwise. The phenomenon is called optical activity. Such substances are said to be optically active, and chiral compounds are optically active compounds, and achiral compounds are optically inactive. So optical activity can be demonstrated like this. When a plane polarized light passes through a certain substance or solution, its plane of polarization is rotated either towards the right or towards the left. So in this diagram, you can see that this is the light source, and this is the Nicol prism, and this is analyzer, and here Nicol prism polarizer and analyzers are in same direction. The alignment is the same direction. If you view this light from here, the light will be permitted. So they are parallel, and an optically active substance is here, and polarized light can get through this analyzer. And in the second case, if you rotate this analyzer and they are crossed, the polarizer and analyzers are crossed, and now optically active substance is there. So the light will not be permitted through this analyzer. So because this has a different plane. And next figure, you have a sample substance containing chiral compound in between polarizer and analyzer. What happens? You see that the plane of polarization will be slightly shifted either towards the right or left. If you are viewing from here, in this particular case, this is shifted towards the left from the observer's point of view. And to get the light permitted, you have to rotate this analyzer towards the left direction. And optical activity, what is meant by dextro and levorotatory? Optical active compound rotates the plane of polarization clockwise. It is called dextrorotatory, and it is indicated by plus or D. And optically active compound rotates the plane of polarized light counterclockwise. It is levorotatory, and it is indicated by minus or L. And you can see it here. It is demonstrated here. You have a sample cell here. This is polarizer and analyzer. And these active substances, particularly active substances, they shift the plane of polarization towards the right. You are viewing this from here. So the analyzer has to be shifted towards the right to get the light permitted through this light, this analyzer. And in this particular case, you have to shift this analyzer towards the left to get the plane of the light to get permitted. So this is the dextrorotatory and this is levorotatory. And what is meant by specific rotation? The degree to which an optically active compound rotates the plane of polarization can be measured by an instrument called polarimeter. Optical activity of a substance, that is extent of rotation, is measured by using a polarimeter and is reported in terms of specific rotation. Sample is placed and analyzer block all light and it has to rotate. Analyzer has to rotate till the light passed and can measure the angle of rotation. That is called observed rotation, and this observed rotation will be characteristic for each compound, and it depends on the number of chiral molecule, the length of the tube, and concentration of the compound. And what is specific rotation? The number of degrees of rotation caused by a solution of 1 gram of compound per 1 ml of solution in a sample tube contains 1 decimeter long at a specific temperature and wavelength. This is the definition of specific rotation, and it is calculated from this formula. And here alpha means rotation observed in degrees, and L means the length of the solution, C means the length of the tube, and C means the concentration of the solution. T, this T stands for Kelvin temperature, and lambda is wavelength of incident light. So the measured observed rotation for specific rotation for glucose is plus 52.7 and sucrose it is plus 66.5. And what are the elements of symmetry? If a molecule has 2 or more orientation in space that are indistinguishable, it possesses symmetry. So it has a 2 more orientation and it is indistinguishable. It means it possesses symmetry. A symmetry element is sometimes maybe line, or plane, or a point, or through an object about which a rotation or reflection leaves the object in an orientation indistinguishable from the original. There are 4 kinds of elements of symmetry: plane of symmetry, axis of symmetry, alternative axis of symmetry, and center of symmetry. Plane of symmetry, mirror plane. Plane of symmetry is an imaginary plane passing through an object or a molecule, and it divides in such a way that one half is the reflection of the other. For example, in the case of cube, you have many planes of symmetry, and this has a symmetry, plane of symmetry, because it can equally divide like this and like this, and 3 ways shown here. And it has an equal half, so it has a plane of symmetry. For example, beaker also has a plane of symmetry and it is equally divided. And in the case of compound, in this particular compound, it has a plane of symmetry and this is equally, this has this indistinguishable part like this. So this molecule has its plane of symmetry. Axis of symmetry is based on rotation axis and a line about which a rotation of molecule through a certain angle and which results in equivalent configuration. So if this is water molecule, oxygen, hydrogen and hydrogen, is the axis of symmetry, and if it rotates in any angle, so you get an indistinguishable molecule. So through this axis of rotation. So it has an axis of symmetry. So alternative axis of symmetry is a little bit different. It's a line about which a rotation of molecule through certain angle and followed by reflection across a plane perpendicular to its yield equivalent configuration. That is alternative. The fourth one, center of symmetry, center of inversion. In a molecule, straight line drawn from any atom projected through the center of molecule, it encounters an equivalent atom and equidistance. So in this particular example, you can see that this has a center of symmetry, this CH3 here and this CH3 here. in equidistance, and this is chlorine also in equidistance. This has a center point of symmetry or center of inversion. And what is mean by asymmetric molecule and symmetric molecule or chiral molecule? A molecule with no elements of symmetry of any kind is called asymmetry. So we have discussed the elements of symmetry, 4 kinds. If a molecule has no elements of symmetry, it is called asymmetry. A molecule non-superimposable on its mirror image is called dissymmetric or chiral molecule. A chiral object has a mirror image, but it should be different from original one. So this glass, for example, glass and its mirror images are indistinguishable. They are superposable. Whereas the mirror image of right hand is the left hand, and they are left and right hand are not superimposable. It is it is called the chiral handedness. That is, the name comes from handedness, the chirality. So chirality means the molecule with a non-superimposable on its mirror image. So optical isomerism is the type of stereoisomerism in which isomers resemble in most of their properties but differ in their behavior towards plane polarized light and optical activity. A chirality is a necessary condition for optical isomerism caused by one or more asymmetric carbon atom whose 4 valencies are satisfied by 4 different atoms. So in this chiral carbon, it is attached to 4 different atoms, and this is the mirror image, and this is a non-superimposable mirror image. So a chiral carbon atom bonded to 4 different atoms is a chiral center, and this is chiral center or chirality center. For example, 2-bromobutane, and this is attached. This carbon is attached to 4 different atoms, and this is the mirror image. And these are the 2 isomers of 2-bromobutane, and this does not have any elements of symmetry. Whereas in this particular case, you have an elements of plane of symmetry here, and this half is same as the other half, and you can see that it has a plane of symmetry, and it is compound, and it is a chiral compound. Whereas if you substitute one of methyl with a ethyl group, it becomes chiral because this does not have a plane of symmetry now. So, in summary, when a plane polarized light is passed through a certain substance or solution, its plane of polarization is rotated either towards right or towards the left. The phenomenon is called optical activity. Such substances are said to be optically active. A molecule with no elements of symmetry of any kind is a symmetric molecule. A molecule non-superimposable on its mirror image is called dissymmetric molecule or chiral molecule. And chiral object has a mirror image but different from the original one. That's all. Thank you for watching.